In this video, I'm going to investigate the connection between a dot plot and a histogram and talk briefly about when I would use one over the other. On the left, we can see part of a spreadsheet of the data, and on the right is a dot plot of the variable age for the 507 adults in this sample. The first person listed in the spreadsheet is a male who is 21 years old, and we can see him right here as part of this stack of individuals at 21. The last person in the spreadsheet, let's go down and find that person, is a female, and she's 38 years old, so she is part of the stack of dots at 38. Now, as we have seen before, a dot plot is useful in determining the shape of a distribution. This distribution has a right skew. We can also see the minimum and maximum values, so we can calculate the overall range. For example, here, the youngest person is 18, and the oldest person is 67. The difference between 67 and 18 is 49, so that's the range. But a dot plot is not good for answering questions like these. How many adults in the sample are under 30 years of age, or what percentage of the sample is under 30 years of age? It's difficult to answer these kinds of questions with a dot plot because we can't easily count up the number of individuals in any given interval. For example, how many people are under the age of 30? Geez, I don't know. All of these people, a lot of them. So in this case, a histogram is a better choice when we want to find counts and percentages. So what I'm going to do now is change this dot plot into a histogram, and the program that I'm using allows me to do this. But you will have a much more efficient way to create a histogram in StatCrunch. What I'm doing now is just a demonstration to help us better understand histograms and how they relate to dot plots. So I'm going to start by putting the data into bins. Whoops. There we go. And because it's easier to count by fives, I'm going to start the first bin at 15 and make the bin widths 5. Okay, so let's click on a few dots and verify that we understand what's happening here. In this first bin, there are 26 individuals, and everyone in this bin is at least 15, but less than 20 years of age. Let's just look at a few of these people quickly in the spreadsheet. Here's a female, she's 19. Here's a male, he's also 19. Here's a female, she's 18. Now notice that I can still see that the distribution's right skewed, but at this point I've lost the ability to see the ages of the youngest and the oldest person in the sample. And that's one of the disadvantages of binning the data, is that I can't see the minimum, the maximum value. But there are advantages. By creating these bins, we can more easily see how adults in the sample, or how many adults in the sample are under 30 years of age. And if I look at the different bins, I know I just need to count up how many people are in these first 3 bins. I need to add 26, 154, and 117. Adding the people in the first 3 bins, I get 297. So there are 297 people in the sample that are under the age of 30. Now let's see if we can determine what percentage of the sample is under the age of 30. There are 507 people in the sample. 297 out of the 507 are under the age of 30. So let's divide 297 by 507 to get 0.586. Multiply by 100 to turn this into a percentage, and we can see that 58.6% of the sample is under the age of 30. I'm now going to finish making the histogram. I will simply change each dot into a flat rectangle and fuse these together. Instead of a group of dots in a bin, we now have a stack of flat rectangles. So as I click through this first bin, for example, I can see it's just a stack of flat rectangles, and each rectangle is a person in the spreadsheet who is under the age of 20, but at least 15. Now, the count of the adults in each bin is the height of the bin. In other words, I can just look across at the vertical axis to determine how many people are actually in this first bin, or in this case, with this particular graph, I see the count above as I did before. So the count of adults is the height of the bin, and this makes sense because the bin is really just a stack of rectangles, one for each person. So the height of the stack is the number of people in the bin. Now, a histogram, just like the bin dot plot, can be helpful in answering questions about counts and percentages. For example, if I wanted to know how many people in this sample are at least 50 years old, I would add up the people in the last 4 bins. So I would be adding 11 plus 5 plus 5 plus 2 to get 23 people, or at least 50, in this sample. If I wanted to compute the percentage, I would again just divide by 507 to get 4.5%. This concludes our introduction to the histogram.